Nuclear chemistry, note page 229. So, introduction to nuclear chemistry. What is nuclear chemistry? First thing that you need to recognize is that it says nuclear, and think about the atom. So, nuclear chemistry is the study of reactions that are caused by a change in the nucleus of an atom. And because of a change in the nucleus, the atom actually becomes a different element. Nuclear chemistry, the focus is on the nucleus of the atom, so therefore has nothing to do with electrons. So we basically ignore the electrons in this unit, and we just focus on the contents of the nucleus, the protons and neutrons. So remember, we've been talking about different types of changes that occur. Physical changes, chemical changes, energy changes, changes in the amount of order, and now we're going to talk about nuclear changes. All of these changes occur because the matter or the system has a certain amount of instability, so it's unstable, and it goes through some sort of change to become more stable. So the stability of a nuclei is based on the ratio of protons to neutrons. And the most stable nucleus has a 1-to-1 ratio of protons to neutrons. And if you take a look over at this graph on the side, where it says P equal N, this is a perfect 1-to-1 ratio. So that's the 1-to-1 ratio belt. But as you notice, the number of protons, which we refer to as the atomic number of an element, as the atomic number increases, you'll notice that the true ratio of the elements, protons to neutrons, starts to move away from the 1-to-1 ratio. And the larger the atomic number, the farther it bends away from the perfect to 1-to-1 ratio. So elements with an atomic number greater than 83 are naturally considered or known to be radioactive because they all have an unstable nucleus. So I would find on your periodic table, I would find atomic number 84, and I would write radioactive above. Okay, so now smaller atoms, atomic numbers less than 83, so we'll just write atomic number is considered less than 83. The nucleuses tend to be stable, and so the most common isotope is not naturally radioactive. So some exceptions that we can point out, because as you know, carbon has 3 distinctive isotopes, and most people, because of their studies in science, are really familiar with carbon-12, and they are familiar with carbon-14. And from your earth science days, you should know that carbon-14 is radioactive, right? And it has been used in what's known as carbon dating to determine the age of a fossil. So if you take a look at the periodic table and you look at the average mass, so if you look at carbon's average mass on the PT, and that average mass is the atomic mass, so the average mass of any carbon atom is like 12.011, right? Notice that carbon-12, its mass number is pretty similar to the average mass. Okay, so these are very similar. And carbon-12 is stable, so it is not radioactive. But this mass number of 14 is really different So I'm going to write very different compared to the average mass, and this is radioactive. So here we go, back up to the notes. When an atom's mass is, I'm going to write very different than its average mass, and that's the one listed on the PT, the atom will be unstable.